Hi, I'm Paul Dansbach and welcome to Fire Engineering's Training Minutes. In today's session, we're going to look at the construction materials and techniques used to construct a lightweight wood frame building. The building that we're in is being constructed as a 3-story hotel. The construction of this building employs lightweight parallel cord wood trusses for the floor system and lightweight peaked roof trusses. Some of the fire problems and collapse potentials associated with lightweight parallel cord trusses are the result of the poor surface to mass ratio as a result of the open web truss construction. Another problem associated with this particular type of truss is the metal gusset plate. The metal gusset plate acts as a heat sink, conducts the heat into the fibers of the wood, allowing the gusset plate to release, and the connection will therefore come apart. As we pan through the truss space above us, we also notice when the drywall is installed along the bottom cord of the truss, we have a very large, wide open combustible void space for the fire to extend and grow in intensity. Fires that do extend up into the combustible void space often result in a large area of a floor collapse as a result of the truss's exposure to the fire. It should be noted in this particular building, the combustible void space created by the trusses is being protected with automatic fire sprinkler protection. This will not be the case in every building that firefighters are called to fight a fire in that is constructed with parallel cord wood trusses. The problem with the steel gusset plate connectors is that it's a dissimilar material to the wood. Under fire conditions, the steel reacts differently from the fire. The steel conducts the heat into the fibers of the wood, starting to char the lumber. The gusset plate will also have a tendency to warp as the result of its exposure to the heat and pull out of the lumber. As in most building construction features, the connections are often the weak spot in the structural system, especially when exposed to fire. In this case, that is very true of the steel gusset plate. There are several areas of the building where firefighters might expect to find a fire separation or a fire barrier of the concealed spaces, to separate the concealed spaces into smaller areas. One such area is the wall that separates the corridor from the dwelling unit or from the hotel room. The contractor in the construction of this building has decided to install the drywall on the ceiling and the walls of the corridor about 2 foot down from the ceiling to maintain the integrity of this fire barrier. The wall behind me is a wood frame wall that's a non-bearing partition. Non-bearing meaning that it does not support the floor or the roof above, it merely supports itself. If we look above, we see the roof trusses. The roof trusses run from the corridor wall, which is a bearing wall, to the exterior wall, which is a bearing wall. When we say bearing wall, we mean that those walls are the walls that support the weight of the roof trusses. If we look at the roof truss and the dimension created, the distance between the roof trusses, between the top and the bottom cord, the roof trusses have a dimension of between 3.5 to 4 feet between the top and the bottom cord of the trusses. The floor trusses, conversely, have a dimension of about 20 inches between the top and bottom cord of the roof trusses. As we look at this roof truss and we look up towards the peak of the roof truss, we notice that our distance between the top and bottom cord increases to about 8 feet. The large volume of combustible void space created by the distance between the top and bottom cord of the trusses is an area where fire can grow in intensity, weaken the trusses, and result in a large area of collapse. When firefighters encounter a fire in a lightweight wood frame building under construction, firefighters should anticipate rapid fire development and early collapse of the building as a result of the trusses being immediately exposed to the fire. Another hazard that firefighters may face in a building under construction is the elevator shaft. In this building, we have 2 elevators in a single shaft. The shaft may result in rapid fire development and vertical fire extension, as well as representing a fall hazard should the barriers, the temporary barriers, not be in place during a fire incident. One of the unique construction features of this type of wood frame building is that the floor systems are almost 3 independent floor systems. If we look into the hotel room, we see lightweight wood trusses. Those lightweight wood trusses bear on the exterior wall and on the corridor wall. From the corridor wall, across the ceiling of the corridor to the corridor wall on the opposite side is dimensional lumber. It's a 2x8. Once we go into the hotel room, on the other side of the corridor, we have another lightweight parallel cord wood truss. What this means for the firefighter is that if the floor in one unit becomes spongy and soft and starts to weaken, the firefighters evacuate that room, cross the corridor on another floor system, and go into the hotel room on the opposite side of the corridor. They are one full floor system away from the floor that's in danger of collapse. Firefighters should be aware of the hazards associated with parallel cord lightweight floor trusses and peaked lightweight roof trusses. Thank you for watching this session of Fire Engineering's Training Minutes.